Today we're going to talk about the pros and cons of induction and servo motors and how their differences can affect the motor selection for your application. First up is the torque density. For an equivalent sized motor, you'll generally get 40 to 60% more torque out of a servo motor. So if compact design or weight savings are crucial for your application, a servo motor may be the way to go. Next up is the inertia, and this is similar to the torque density. Because of the compact nature of servo motors, they'll generally have a lower inertia. This is highly beneficial for applications that require quick moves or rapid cycle times. Conversely, some applications like crushers benefit from the high inertia of induction motors. Now let's talk about torque curves. Before selecting a motor, you should know your required torque and speed across the full operating cycle. If you need high torque at low speeds, servo motors are the way to go because they can provide full torque across the full speed range, including zero speed. Next up is efficiency. If you supply the same electrical energy into an induction and servo motor, you'll generally get more mechanical power out of the shaft from a servo motor. So if you're looking for the most efficient solution, the servo motor is again your best choice. Last up is the cost, and this is where the induction motor shines. The gap has closed in recent years, but generally the induction motor will be cheaper than a servo motor. If the advantages of the servo motor that we've talked about aren't required, the induction motor and its cost savings can be a huge benefit. So when selecting a motor, it's important to look at all requirements of the application. If the performance advantages of the servo motor are required, that's the way to go. If not, the induction motor and its cost savings can be a great choice. If you want to learn more about induction and servo motors, check us out at KEB America.